April 8, 1943. 27,000 feet over occupied France. Oberleutnant Rolf Hermeken watched from his cockpit as the first wave of American fighters climbed toward his formation. To a veteran ace, the incoming silhouettes looked less like threats and more like easy targets. Hermeken radioed his wingmen, describing the Americans as flying milk bottles. Below them, 16 Republic Thunderbolts were laboring for altitude. At 7 tons each, their engines were audibly straining just to maintain formation in the thin air of the stratosphere. The P-47 appeared comical compared to the sleek Focke-Wulfs. It had a barrel-shaped fuselage, wings that seemed too small for its mass, and a propeller that dwarfed anything in the Luftwaffe inventory. The Germans began their descent, assuming the ungainly machines would be easy to outmaneuver. They were diving into a trap designed by engineers who prioritized physics over aesthetics. Inside those wings sat a row of 8 synchronized 50-caliber Browning machine guns, representing an unprecedented level of airborne firepower. This chart compares standard fire volume against the P-47's payload. While typical fighters peaked at 1,000 rounds per minute, the Thunderbolt hit 6,000. At 400 yards, that energy saws a Messerschmitt in half in under 2 seconds. The American pilots in the sky that morning had 0 days of combat experience. They were facing the most seasoned fighter force in the world, men who had been flying continuously since the invasion of Poland in 1939. But the Americans brought a different variable to the fight. Over the next year and a half, the Luftwaffe would discover that years of tactical experience offer very little protection when the air itself is filled with 6,000 rounds of lead every minute. Major Donald Blakesley knew that if his men tried to dogfight in the traditional sense, they would be slaughtered. The Thunderbolt was not designed to dance with the enemy. European design focused on lightweight interceptors like this Messerschmitt 109. These were specialized tools optimized for climb rates and tight horizontal turns. Republic Aviation ignored that trend. They built a juggernaut that relied on mass and raw engine power to dictate the terms of the engagement. By treating aerial combat as a problem of physics rather than finesse, they created a machine that could survive hits that would destroy a lighter aircraft, while using its weight to plummet through the sky at speeds no German could match. The P-47 was a product of the 1940 panic. Republic Aviation received urgent orders to build a high-altitude interceptor capable of challenging the Luftwaffe at the edge of the atmosphere. The resulting prototype weighed nearly 10,000 pounds empty. It was 65% heavier than the fighter it replaced, leading many test pilots to wonder if it would even get off the ground. This X-ray diagram shows the internal layout that necessitated that massive frame. The rear half of the fuselage is dedicated to a complex turbo supercharger system. Hot exhaust gases are routed through these ducts to spin a turbine, forcing compressed air forward into the engine. This mechanical loop allowed the 18-cylinder engine to maintain sea-level horsepower at 27,000 feet, the exact altitude where German engines typically began to lose power in the thin air. By conquering the stratosphere, the P-47 gave American pilots the ability to loiter above the enemy, choosing exactly when to dive and unleash their weight on the fighters below. Mastering this power proved lethal. During training in Connecticut, the P-47 killed 18 American pilots in accidents before they ever saw a German plane. The plane was violent on the ground. If a pilot was too aggressive with the throttle, the engine's torque would roll the entire 7-ton airframe over on takeoff. On landing, it was prone to ground looping, spinning out of control the moment it touched the runway. In high-speed dives, pilots encountered a new hazard: compressibility. As the plane neared the speed of sound, shock waves would form over the wings, causing the metal to shudder violently. In these moments, the flight controls would freeze completely. The P-47 would become a multi-ton, unsteerable meteor, plummeting toward the Earth until the air thickened enough for the pilot to regain control. The pilots had to learn to survive the physics of their own machine before they could hope to use it as a weapon. Once the survivors learned to stay at high speed and high altitude, the P-47 became nearly untouchable. The cockpit no longer felt like a traditional airplane. As ace Robert Johnson described it, it was like being strapped to a locomotive. You didn't fly it, you aimed it. The results of that transition are visible in the kill tallies of the 56th Fighter Group. Over 18 months, they used the Thunderbolt to systematically dismantle the Luftwaffe's fighter arm. The P-47 succeeded because it proved that in modern war, tactical skill is ultimately secondary to physics. When 8 heavy guns are aimed with 2,000 horsepower behind them, the result is inevitable. In April 1943, the American P-47 Thunderbolt arrived in Europe and immediately struggled to survive. In its first combat encounters, the massive aircraft couldn't climb with the German Messerschmitt 109s, and it lacked the nimble handling needed to match the Focke-Wulf 190 at medium altitudes. Luftwaffe pilots quickly refined their tactics to exploit the Thunderbolt's weight. They attacked from below, where the heavy fighter was at its most vulnerable, forcing the Americans into turning fights where their lack of agility became a death sentence. The German command viewed the new arrival with open contempt. Hauptmann Josef Pips Priller reported that the plane turned like a freight train and climbed like a pregnant cow. His pilots began calling them Indiana, fat targets pretending to be warriors. This chart of the first month of combat operations reveals the scale of the disaster. The American fighter groups lost 14 Thunderbolts while securing only 3 confirmed German kills. Even the British RAF, observing from their Spitfire squadrons, suggested the Americans reconsider their choice of aircraft. British pilots joked that the only effective evasive maneuver in a P-47 was for the pilot to unstrap and run around the cavernous cockpit. Between the initial kill ratios and the scathing combat reports, the Thunderbolt appeared to be a massive, expensive failure, entirely unsuited for modern dogfighting. However, German intelligence overlooked a critical anomaly in the debris. The Thunderbolts that were actually shot down had survived an extreme volume of structural punishment before finally falling. The engineering behind the cowling set the P-47 apart. While European fighters relied on fragile liquid coolant systems, the Thunderbolt utilized a massive radial engine that could absorb direct hits and keep turning. This schematic illustrates the aircraft's offensive trade-off. 8 heavy machine guns were synchronized to create a single concentrated zone of destruction. When a P-47 pilot finally got a German plane in his sights, the result was total disintegration. Unlike early warfighters with limited cannon shells, the American aircraft could maintain this wall of fire for over 30 seconds, an eternity in a high-speed dogfight. Republic Aviation had designed a flying tank, a machine capable of surviving lethal combat damage while delivering overwhelming, sustained firepower. On June 26, 1943, over Forges-les-Eaux, France, 2nd Lieutenant Robert S. Johnson entered a combat engagement that would prove the limits of that engineering. Johnson was flying at the rear of his formation when the air war turned against him. 16 Focke-Wulf 190s executed a textbook ambush, diving out of the sun with an overwhelming speed advantage. They targeted the rear of the American formation with clinical precision. Johnson's Thunderbolt took 21 20mm cannon shells. In the first seconds of the attack, the canopy shattered, the instrument panel erupted in flames, and burning hydraulic fluid sprayed into the cockpit. Wounded by shrapnel, Johnson tried to bail out, but discovered he was trapped. A cannon shell had exploded in the canopy track, welding the steel shut and sealing him inside a dying aircraft at 27,000 feet. In less than a minute, Johnson's mission had devolved into a claustrophobic, inescapable fight for survival in a cockpit filled with smoke and fire. With zero visibility through his oil-covered windscreen and a violently shaking engine, Johnson managed to level the aircraft. He used intermittent controls to point the nose toward the English Channel and hope for the best. A lone German pilot soon spotted the crippled fighter limping home at less than 170 miles per hour. Seeing an easy kill, the Focke-Wulf moved in for the finish. The German positioned himself directly behind Johnson and unleashed his full battery, 4 20mm cannons and 2 machine guns. Heavy shells and machine gun fire slammed into the Thunderbolt's fuselage. Unable to evade, Johnson huddled behind his seat's armor plate and braced for the airframe to shatter. He was entirely at the mercy of the P-47's structural integrity. The German pilot exhausted his entire supply of cannon ammunition into the target. He then repositioned and fired again, using his remaining machine guns to pepper the tail and cockpit. By any standard combat metric of 1943, the aircraft should have been a cloud of falling debris. Instead, despite taking the full ammunition load of a German fighter, the incredible machine just continued to fly. Out of ammunition, the German pilot pulled alongside the shredded wreck to see why his target was still in the air. Through the shattered glass, Johnson could clearly see the German's face. He watched the pilot's expression shift from professional confidence to confusion, and finally to something approaching fear as he realized the American plane was seemingly indestructible. The German attempted one final desperate volley of machine gun fire. He emptied his remaining rounds into the Thunderbolt's wings and engine, but the plane refused to go down. The German pilot pulled alongside one last time, shook his head in apparent amazement, and gave Johnson an informal salute before peeling away. The P-47's mechanical durability saved Johnson's life, while simultaneously shattering the psychological superiority and legendary confidence of the Luftwaffe's elite pilots. When Johnson finally landed at Manston, ground crews stopped counting bullet holes after reaching 200. This structural analysis shows how close he came to total failure. 3 of the 4 main longerons, the backbone of the entire aircraft, had been shot completely through. The visual inspection of the cockpit revealed the margins of survival. One cannon shell had detonated against the armor plate directly behind Johnson's head, while the massive radial engine had swallowed multiple direct hits that would have instantly stopped any other fighter. The condition of the wreckage shocked American engineers, while German intelligence initially refused to believe the pilot reports, claiming no aircraft could absorb that volume of fire and stay airborne. Multiple pilot testimonies eventually confirmed the impossible resilience of the Thunderbolt. It had taken everything the Luftwaffe's best interceptor could deliver and brought its pilot home. In the brutal attrition of the European theater, the P-47 proved that survival was a strategic asset. Republic Aviation had created a machine capable of flying through hell, ensuring its pilots lived to fight the next mission. By July 1943, American pilots changed their approach to the skies over Europe. They stopped trying to outturn the lighter German fighters and instead began to exploit the P-47's 8-ton weight. At high altitude, that raw tonnage turned the aircraft into a falling anvil. In a dive, a P-47 could reach 550 miles per hour, making it faster than any German fighter, even those in a vertical plunge. American formations used this weight to perfect the boom and zoom tactic. They would climb to 30,000 feet, dive on targets below, and then use their massive kinetic energy to zoom back to altitude. This left German defenders behind, unable to follow the Americans into the thin air. The sheer velocity of these dives broke standard defensive geometry. The Thunderbolts moved so rapidly that German pilots found it impossible to calculate the lead required for a deflection shot. By the time they could aim, the Americans were already out of range. By merging gravity with raw tonnage, American pilots gained a physical advantage that German fighters could not counter. The Thunderbolt functioned as an airborne guillotine, dropping on targets with a force that made evasion impossible. The effectiveness of this brute force was demonstrated during the August 1943 raids on Schweinfurt and Regensburg. High above the B-17s, a flight of 4 Thunderbolts spotted a formation of Messerschmitt 110s, heavily armed bomber killers that were now sitting targets for a high-altitude ambush. Unteroffizier Heinrich Roth, a gunner in one of the 110s, later recalled the terror of the attack. He fired on the leading P-47 at 800 meters and saw his hits strike the wing. The heavy American fighter didn't even wobble. Its armor simply absorbed the defensive fire. Then, the American pilot fired back. Roth watched the aircraft ahead of him disintegrate. In 2 seconds, the wings separated from the fuselage and the crew compartment was shredded. 8 Messerschmitts were destroyed in less than a minute. This structural annihilation was the result of massive ammunition loads. A single P-47 carried 3,400 rounds of half-inch projectiles, weighing nearly 900 pounds, enough firepower to ignite and destroy anything in its path. This diagram shows the geometry of the kill. The ballistic paths of all 8 machine guns were set to intersect precisely at 300 yards. This created a zone 6 feet in diameter where 100 projectiles struck every second, each traveling at 2,900 feet per second. This timeline chart compares the American industrial advantage to the German reality. While Luftwaffe pilots carried limited cannon ammunition, often only enough for a few seconds of fire, the P-47 pilot could maintain a continuous stream of lead for over half a minute. When you combine 8 intersecting ballistic paths with half-minute firing windows, survival becomes a matter of statistics. Once a German pilot entered that convergence zone, the volume of fire ensured his aircraft would fall apart. The P-47's dominance was anchored in aerospace engineering. Its turbo-supercharged double-wasp engine was designed to breathe perfectly in the thin air at 30,000 feet, allowing it to maintain full power while other aircraft struggled. German fighters relied on mechanical superchargers that suffered above 25,000 feet. At these altitudes, their engines gasped for oxygen, causing the aircraft to become sluggish and unresponsive. This mechanical limit proved fatal for Oberleutnant Hans Philipp, one of Germany's most successful aces with 206 victories. On October 8, 1943, while intercepting B-17s at 28,000 feet, Philipp found himself trapped in air his engine couldn't handle. His Focke-Wulf 190 wallowed in the thin atmosphere, its maneuverability gone. When P-47s of the 56th Fighter Group dove from 32,000 feet, the German formation had no way to fight back or escape. American pilot Robert Johnson spotted Philipp's aircraft and closed the distance. His combat report was clinical. Opened fire at 300 yards, 30-degree deflection. Observed strikes along entire fuselage. Enemy aircraft exploded. One of Germany's greatest pilots was dead in seconds. Philipp's death shook the Luftwaffe. If a veteran of 500 combat missions was defenseless against the Thunderbolts, the average German pilot felt he had no chance. A sense of panic began to spread through the fighter wings. The report delivered to Hermann Göring in November confirmed the crisis. The Thunderbolt could reach 42,000 feet, higher than any German fighter. It was shielded by heavy steel and bulletproof glass, and its rugged construction allowed it to survive damage that would destroy multiple conventional aircraft. The P-47 defeated the Luftwaffe by weaponizing the air itself. It was a flying manifestation of American industrial supremacy, an aircraft that could climb higher, dive faster, and hit harder than anything the German military could produce. In January 1944, a new variant of the P-47 Thunderbolt arrived in England. Up until this point, German pilots had openly mocked the American fighter as a flying pig. That was about to end. The transformation started at the nose. Engineers equipped the P-47 D-22 with a Hamilton Standard hydromatic propeller. It measured 13 feet across, featuring broad paddle blades designed to bite into the air like massive oars. This chart shows exactly what that massive propeller accomplished. Earlier Thunderbolts struggled with an anemic climb rate of 2,200 feet per minute at sea level. The new paddle blade variants jumped to 3,000 feet per minute, a trajectory that allowed them to match or exceed the climb rate of standard German fighters at almost any altitude. Hauptmann Heinz Nock, a Luftwaffe veteran with over 200 combat missions, encountered these new machines in February 1944. Patrolling near Hanover, his flight spotted a P-47 formation and dove in, expecting their usual tactical advantage. Instead of being easy prey, the heavy American fighters immediately turned and climbed with them. When the Germans tried to break off, the Thunderbolts followed them all the way up to 30,000 feet. Nock recorded the result in his diary. His wingman, Schmidt, was caught and blown apart, leaving nothing but smoke and fragments. Nock wrote, "These are not the same machines we laughed at last year." This mechanical upgrade had a secondary side effect. Because the new propeller was so large, the tips of the blades actually reached supersonic speeds. This created a distinct thundering roar that could be heard from miles away. German ground troops quickly learned to identify approaching P-47s by this deep rumble. Before the aircraft even broke over the horizon, the sound signaled incoming destruction, earning the plane a name among the infantry, Donnerschlag, thunderclap. By March 1944, the Thunderbolt extended its reach. Crews began mounting 108-gallon fuel tanks under the wings, or a 75-gallon tank beneath the belly. This pushed the P-47's operating range past 1,000 miles, allowing it to escort Allied bombers deep into Germany. The Luftwaffe's response was to target the bomber streams directly, attempting to inflict enough losses to halt the American daylight campaign. But to reach the bombers, German pilots now had to fly straight through a screen of heavily armed P-47 escorts. Major Günther Lahl, a German ace with 275 victories, experienced this on March 6th. Seeing the heavy silhouettes above, one of his pilots joked over the radio about the flying pigs. 30 seconds later, the P-47s dove. Rao later recalled that the American fighters came down like an avalanche, moving faster than his pilots could react. The first pass destroyed 3 German fighters. Rao noted a distinction in how the Thunderbolts attacked. German interceptors typically fired in bursts, but the heavy American fighters poured out a continuous, solid stream of fire. Any aircraft caught in that stream was instantly shredded. This combat exposed a massive endurance gap. German interceptors relied on maximum power settings that rapidly burned through fuel. Meanwhile, the Thunderbolt's radial engine cruised efficiently at high altitudes, allowing the Americans to loiter over the bombers for hours and still maintain enough fuel for combat and the return flight. In April 1944, P-51 Mustangs began arriving in force to take over long-range escort duties. This released the Thunderbolt squadrons to drop their altitude and focus on a new mission ahead of the invasion of France: ground attack. Looking at this schematic of a German transport truck, we can see the impact of a P-47 strafing run. The aircraft's 8 heavy machine guns fired armor-piercing incendiary rounds. In a single 2-second burst, those guns clustered 160 projectiles into an area exactly this size, penetrating engine blocks and igniting fuel. The machine guns were just the baseline. The D-25 variant could carry 2 1,000-pound bombs under the wings, plus an additional 500-pounder under the fuselage. Finally, engineers added rocket stubs to the wings, allowing the P-47 to carry 10 5-inch high-velocity aircraft rockets. A single strike from one of these HVARs delivered the explosive force of a 105mm artillery shell. By mounting medium bomber payloads and artillery-grade rockets onto a fast, armored fighter frame, the Allies created a tactical platform capable of dismantling ground defenses that were previously unreachable by air power. Oberst Hans von Luck commanded a Panzer Grenadier regiment during the Normandy campaign and faced these attacks firsthand. He described the terror of massive fighters coming in so low to the ground that his men could clearly see the American pilots' faces. The damage was total. Von Luck watched an entire column of 20 German trucks simply cease to exist in a single pass. He noted that while his men called them jabos, they operated more like flying artillery with the accuracy of a sniper. On June 6, 1944, the Luftwaffe realized how completely the balance of power had shifted. Over 500 P-47s formed an air umbrella over the landing beaches, sealing off the airspace for any German aircraft attempting to reach the coast. Oberlieutenant Wolfgang Fischer was one of only 3 German pilots to reach the invasion zone that day. He attempted to break through with 12 fighters. He was the only one to return. Fischer reported that the airspace was choked with P-47s, stacked from sea level to 30,000 feet. Their overlapping fire turned the German interceptors into aluminum rain. In the weeks that followed, this dominance expanded. In June alone, 9th Air Force Thunderbolts destroyed 651 locomotives, over 3,800 trucks, destroyed 512 tanks, and more than 4,500 horse-drawn transports. The Wehrmacht tried reinforcing vehicle armor and deploying more anti-aircraft batteries, but nothing worked. Even the feared 88mm flak gun struggled to track the speed of the Thunderbolts at low altitude. The cumulative effect of these technical and tactical evolutions was the total paralysis of German military movement during daylight hours. By forcing the Wehrmacht to move only under the cover of darkness, the P-47 systematically stripped away their ability to respond to Allied advances on the ground. The immense distances and brutal weather of the Pacific War demanded severe endurance from American aircraft. On October 11, 1943, Colonel Neil Kirby led a flight of 4 P-47 Thunderbolts over WWII, New Guinea, tearing through 40 Japanese fighters. Kirby shot down 6 enemy planes himself in a single afternoon. That performance earned him the Medal of Honor. Japanese aviators, who were highly accustomed to dogfighting with nimble, lightweight American fighters, themselves completely unprepared for an opponent wielding this level of massive durability and heavy firepower. Saburo Sakai, a legendary Japanese ace, noted that his 20mm cannon, which could easily destroy a P-40 in a few hits, bounced off the Republic fighters. He reported pouring dozens of rounds into a single Thunderbolt, only to watch it fly away, while the heavy return fire from the American planes tore Japanese aircraft apart. Republic Aviation adapted the aircraft specifically for these massive oceanic distances by developing the P-47N. They designed wet wings holding 93 gallons of fuel each, stretching the fighter's operational range to 2,350 miles, so it could escort B-29 bombers all the way to Japan. By solving the geographical constraints of the Pacific, American engineers evolved the P-47 into a long-range escort capable of projecting power across thousands of miles of ocean. In the European theater, Allied pilots encountered a vastly different threat. The German Messerschmitt Me-262 reached top speeds of 540 miles per hour. A jet of this caliber should have been completely untouchable by propeller-driven fighters. But American pilots analyzed the flight characteristics of the jets and isolated two vulnerabilities. The Me-262 was dangerously slow during its takeoff and landing phases, and it could be caught from above if a heavy fighter entered a massive, high-speed vertical dive. On November 27, 1944, Lieutenant Colonel John C. Meyer pushed his heavy Thunderbolt into a vertical dive from 28,000 feet. Gravity and mass worked together, accelerating his plane to speeds approaching 500 miles per hour, fast enough to drop directly behind a cruising German jet. The German pilot never saw him coming. Meyer opened fire from 400 yards away. His combat report detailed how the concentrated kinetic impact of 850 caliber machine guns caused the jet to instantly disintegrate, separating both engines completely from the fuselage. To hunt these jets systematically, the military introduced the specialized P-47M variant in early 1945. Engineers added water methanol injection systems, boosting the massive radial engine to 2,800 horsepower and pushing the plane's top speed to 470 miles per hour at high altitude. Major George Bostwick deployed these specialized variants using a specific tactical doctrine. He noted that while the jets were faster, they were fragile and could not turn tightly. When German pilots decelerated to target Allied bomber formations, Bostwick's pilots used their overwhelming battery firepower to shred them. American forces neutralized Germany's massive leap in aviation technology by pairing calculated tactical doctrines with raw, overwhelming kinetic firepower. On January 1, 1945, the Luftwaffe launched Operation Bodenplatte. Nearly 900 German fighters flew a desperate surprise offensive to permanently destroy Allied air power across the airfields of Belgium and the Netherlands. At the Y-34 airfield near Metz, the German strike initially succeeded. They caught the 365th Fighter Group on the ground, leaving 22 American Thunderbolts burning on the tarmac. A captured German pilot was brought into the American command post. Looking out the window at the smoking wreckage of the fighter wing, he smiled and taunted his captors, asking what they thought of his Luftwaffe's handiwork. Major George Brooking pointed outside. Ground crews were already bulldozing the destroyed planes off the flight line to make room. Brooking told the prisoner that by tomorrow they would have 40 new aircraft sitting there, and asked how long it would take Germany to replace the pilots they had just lost. Brooking made good on his threat. Within exactly 48 hours, factory-fresh P-47 D-40s were flown directly from supply depots in England, entirely refilling the burning flight line. For the German personnel who witnessed this, the speed of American regeneration exposed a disparity in replacement capacity that the Axis was no longer able to match. This dual bar chart tracks the strategic cost of Operation Bodenplatte. The Luftwaffe lost 271 aircraft and 213 irreplaceable pilots. This permanent dip represents the complete gutting of their flight instructors and leaders. The Americans lost 134 aircraft across all the attacked airfields. As this blue line shows, every single lost airframe was completely replaced with brand new inventory within a single week. That regeneration was fueled by the macro scale of Republic Aviation's output. By the end of the conflict, the United States had produced 15,683 P-47s. The manufacturing pace was relentless. Working around the clock, the Farmingdale and Evansville plants completed one Thunderbolt every hour, 24 hours a day. Industrial volume had effectively decided the outcome, turning every tactical encounter into a component of an unwinnable war of attrition. This exploded view illustrates the staggering complexity: 65,000 parts, 8 miles of wiring, and 2,000 pounds of aluminum. The radial engine contained 2,400 components, each machined to exact tolerances of mere thousandths of an inch to prevent catastrophic failure. This highly specialized labor was performed by an entirely new civilian workforce, composed largely of women who had never worked in heavy industry. They assembled these hyper-complex machines at a speed and precision that heavily exceeded pre-war peacetime standards. Supplying these fleets required a massive logistical tale. A single Thunderbolt sortie consumed roughly 3,400 rounds of heavy ammunition. By mid-1944, the fleet was burning through over 10 million rounds every single month. The Lake City Arsenal in Missouri alone produced 30 million rounds monthly. Every single cartridge had to be manufactured to flawless tolerances, ensuring they would feed reliably through the complex synchronized gun mechanisms at high speeds and extreme altitudes. The true weapon in the Allied arsenal was the unprecedented synchronization of civilian labor and precision engineering on a continental scale. That heavy machinery required an equally massive stream of liquid energy. When flying in combat with the water injection system engaged, a single Thunderbolt burned up to 300 gallons of aviation fuel per hour. The 9th Air Force alone consumed 25 million gallons of fuel monthly. Every drop required transport across the ocean via thousands of mass-produced maritime tankers. But the ultimate logistical advantage was human. By 1944, the American training pipeline was graduating 30,000 advanced pilots annually. Every American fighter pilot entered combat with a mandatory minimum of 400 hours of flight training. Meanwhile, the collapsing German infrastructure forced their new pilots into the sky with less than 100 hours of total flight time. The American curriculum was deeply comprehensive. Trainees mastered instrument navigation, complex deflection shooting, and studied advanced technical manuals detailing the exact weaknesses of the enemy aircraft they would face. Lieutenant Eugene Roberts arrived in England with 420 logged hours. On his very first combat mission, he applied his deep training in deflection shooting to effortlessly engage and dominate a severely undertrained German opponent. Combining indestructible machinery, infinite supply chains, and hundreds of hours of pristine training meant the outcome of the air war was decided by data and logistics long before the engagement began. As Roberts himself put it, it wasn't even a fair fight. In March 1945, German propaganda officials sat down with Oberst Lieutenant Joseph Priller for an interview designed to boost national morale. They wound up burying the tape. 2 years earlier, Priller had openly mocked the American P-47 fighters, dismissing them as pregnant cows. By 1945, his assessment of the aircraft was so bleak that publishing it would have shattered the military's remaining resolve. He described a machine that carried bombs like a medium bomber, fired rockets like artillery, and fought like a nimble fighter when engaged. He told the interviewers the weapons didn't jam, the engines didn't overheat, and the pilots never ran out of ammunition in a normal dogfight. But Priller understood that the aircraft itself was only a symptom of the real problem. The true threat was the relentless, unstoppable industrial engine churning them out. "We lose one, it's gone forever," Priller admitted. "They lose 10, they build 20. Germany was fighting with nothing but courage, and as the officers realized, courage without resources is simply a delayed defeat. American pilots were arriving on the front lines better trained than Germany's surviving flight instructors. They had abundant training fuel, unlimited practice ammunition, and endless replacement parts. Even the acoustic signature of the planes caused panic. Ground forces learned that when they heard the precise mechanical thunder of the P-47 engines, an inescapable attack was imminent. The Luftwaffe was being systematically buried under a mathematical certainty, an avalanche of steel and lead that German industry could no longer match. By April 1945, the Luftwaffe existed mostly on paper. Their experienced pilots were dead or captured, their runways were cratered ruins, and severe fuel shortages grounded almost every operational aircraft. This diagram shows the impossible tactical equation facing any German pilot who managed to get airborne. Formations of P-47s owned every layer of altitude, from ground level all the way up to 40,000 feet. Feldwebel Klaus Bretschneider, one of the last pilots trained that year, flew exactly one combat mission. Over Leipzig, 4 Thunderbolts dove on him in perfect formation. The American leader fired from 500 meters, and Bretschneider's aircraft shook as if hit by sledgehammers before his engine exploded. Floating down in his parachute, he watched those same Thunderbolts dismantle his entire Staffel. 6 fighters were ripped apart in under a minute, showering the sky with burning aluminum and bodies. For pilots like Bretschneider, the sky had become a trap. These brief, violent encounters demonstrated that even high-performance German aircraft were effectively defenseless against the density and speed of the American formations. The constant threat spawned a documented medical condition among German personnel. Medical officers called it Jabo fever, severe physical stress symptoms appearing the moment Thunderbolts were reported in the sector. Hardened combat veterans who engaged British Spitfires and Hurricanes for years without hesitation were now becoming physically ill before missions against the Americans. On the ground, the reaction was pure panic. Infantry units routinely abandoned their positions and scrambled for deep cover the second they heard that distinctive engine noise approaching. The P-47 weaponized anxiety. It neutralized entire enemy units, freezing them in place or forcing them into hiding before a single machine gun was fired. The final statistics from the European theater show exactly why that terror was justified. The 9th Air Force alone dropped 120,000 tons of bombs and fired 135 million rounds of ammunition. They dismantled the German transport network entirely, wiping out 86,000 railway cars and crushing over 9,000 steam locomotives. Ground units fared even worse. Thunderbolts claimed 68,000 trucks and over 6,000 armored fighting vehicles, completely paralyzing the military's ability to move supplies or troops. And this lethality extended across the globe. In the Pacific, P-47 pilots destroyed nearly 700 Japanese aircraft in the air and shattered thousands of vehicles and installations on the ground. With a 4.6-to-1 kill ratio and the lowest loss rate of any Allied fighter bomber, the Thunderbolts systematically dismantled Axis tactical mobility. The human toll was similarly irreversible. Approximately 28,000 Luftwaffe pilots fell to the concentrated fire of American heavy machine guns, losses representing years of specialized training that Germany could never replace. This diagram shows the massive experience gap by the end of the conflict. The average surviving German fighter pilot had less than 30 hours of combat experience. The American flying the P-47 hunting him had over 200. At the Ober-Ursel Interrogation Center, captured Allied pilots were continuously debriefed by German intelligence. The internal files from that center tracked exactly how their view of the P-47 evolved. In April 1943, they labeled it a large, unmaneuverable fighter, classing it as a minimal threat. By June 1944, citing its devastating firepower and incredible structural strength, the file upgraded it to a critical threat at all altitudes. By March 1945, the final entry in the dossier offered no tactical advice for German pilots. The official military assessment for engaging a Thunderbolt simply read, "Unsurvivable." In 1985, at a reunion of American and German fighter pilots in Phoenix, Arizona, the former head of the Luftwaffe fighter arm, Adolf Galland, was asked about the P-47 Thunderbolt. He admitted that back in 1943, his pilots made a terrible error. When they first spotted the massive, bulky American plane in the sky, they laughed. They thought Americans accidentally built a heavy bomber and passed it off as a fighter. The Americans weren't trying to match European dogfighting standards. They purposefully designed a machine engineered for a brutal war of attrition, prioritizing 3 specific traits: mass production, heavy firepower, and extreme survivability. When Galland finally flew a captured P-47 after the war, the mockery vanished. He found an aircraft with an incredibly comfortable cockpit, clear visibility, and an engine so powerful it felt like it was falling upward. The initial laughter masked a fatal reality. American designers had produced an armored platform built to outlast and outgun everything else in the sky, prioritizing attrition over traditional dogfighting. Every single one of these Thunderbolts required an engine far more complex than anything the German war machine was capable of manufacturing at the time. Yet, while fighting a two-ocean war, American factories turned out over 15,000 of these highly advanced fighters, assembling them faster than Germany could build simple interceptors. Looking at that staggering combination of precision engineering and overwhelming manufacturing volume, Galland realized that the war was mathematically lost long before the final shots were fired. The terror really began when the trigger was pulled. The synchronized firing of its 8 heavy machine guns created a distinct, deafening roar. German pilots called it Roosevelt's piano, a sound many heard for the very last time. This diagram shows exactly how over-engineered the airframe was. The wing spars were designed to support 40,000 pounds, 3 times the aircraft's fully loaded weight. Up front, the engine mount was built to withstand a crushing 12 G-forces. To keep it flying under heavy fire, the engineers built in massive redundancy. Look along the fuselage. Every control cable was doubled, featuring automatic backup systems that would engage if the primary lines were severed by enemy fire. Even the ammunition delivery was a marvel. To prevent heavy belts of bullets from jamming during extreme maneuvers, engineers installed dedicated electric boost motors to pull the rounds into the chambers. They even electrically heated the guns to prevent them from freezing solid at high altitudes, and gave each weapon its own independent charging mechanism, so a single failure wouldn't cripple the pilot's firepower. After the war, some veterans tried to claim that German fighters were technically superior, and that America only won by throwing endless swarms of planes at the problem. The combat logs tell a different story. In engagements where numbers were completely equal, the P-47 consistently won. The German 20mm cannons required precise aim and only carried enough ammunition for a few seconds of sustained fire. This visualization illustrates the difference. On the left, a cannon shell requires a perfect hit. On the right, the Thunderbolt's 8 synchronized guns created a wide probability cloud of lead. A simple 2-second burst put at least 20 rounds into a target, guaranteeing destruction even if the pilot's aim were slightly off. The bullets themselves were highly specialized. The American 50 caliber armor-piercing incendiary rounds utilized a delayed action fuse, penetrating deep into the enemy aircraft before detonating. Once inside, the incendiary compound burned at 3,000 degrees Fahrenheit, easily hot enough to ignite structural aluminum. By contrast, those heavy German shells often exploded right on the surface, causing spectacular but sometimes completely superficial damage. A mathematically superior weapon system dismantled the elite of the Luftwaffe. Its design made their destruction inevitable, shifting the air war from a test of skill to a game of probability. Weighing 10,000 pounds empty, the P-47 remains the heaviest single-engine piston fighter ever mass-produced. Its single engine generated more power than entire formations of bombers from the previous World War. Yet this incredibly complex machine was flown into combat by kids barely out of high school and maintained on muddy airfields by mechanics who learned their trade in a matter of weeks. In less than 2 years, the aircraft the Germans had derisively called a flying milk bottle became the most terrifying silhouette in the sky. Veterans who had fought Soviet and British aces without flinching now spoke of the Thunderbolt in hushed, fearful tones. Today, inside the United States Air Force Museum in Dayton, Ohio, a restored P-47 sits quietly on the floor, surrounded by other legendary aircraft. While a placard lists its specifications, the true cost of its engineering is captured in a small glass case nearby. It holds a pile of spent .50 caliber shells, sitting next to a strip of gun camera film that shows a German fighter violently disintegrating. Beneath that film is a quote from a captured German pilot in 1945. It reads, "We laughed when we first saw them. We stopped laughing when we realized they didn't need to turn or climb. They just pointed those guns at you, and you ceased to exist." The laughter died with our comrades. The mighty P-47 Thunderbolt entered the war as an object of ridicule and ended it as an instrument of annihilation. It buried the Luftwaffe under an avalanche of lead, securing total American dominance of the skies.